Hey there, today I'll be covering the custom water-cooled OCV1 by ZS cases. I already did an air-cooled build with it recently, which also covers the specs and basics, so if you want to check out that video afterwards, it will be linked up at the top here. Now, this is by far the most challenging open-air mini ITX case I've ever worked on. Honestly, from the outside, it looks simple as you might think you could just mount stuff on and connect things as you go, but it's not quite that easy. I'll go over my build experience, some general tips when putting it together, and who this case is for. Let's talk about it. So, in my previous OCV1 video, I mentioned how ambitious this case was, to which I am referring to its ability to stack up to a 360 radiator for mini ITX cooling, because most chassis designed strictly for mini ITX normally don't allow or accommodate a radiator of that size. Usually you'll see at most a 240, and I'm talking about both closed and open air cases. In this build, I used the same main components from my black and gold Mobius project. If you have not seen that video, it can also be found on my channel. And because it was using the same components, these two builds are good comparisons as they are both custom water-cooled open-air mini ITX cases. The only differences here would pretty much be the cooling solution used. It's basically a 240 versus a 360 radiator, and some differences with the pumps and res combos. Also, the RAM was swapped out from the G-Skill Trident Z Royals to Corsair's Dominator Platinums. Both kits are rated at the same speed of 3600 MHz and CL16, so there's really no major difference here. Primary reuse parts include the Ryzen 9 5900X, a Strix 3080, Asus X570 ITX motherboard, and the Samsung 980 Pro SSD, all powered by Corsair's RMX 850W power supply. Now with the cooling, I kept the EK3080 water block on the GPU and went with Barrow's CPU block. That is also a DDC pump and reservoir all-in-one triple combo. This thing saves a lot of money and space if you're trying to do a compact build. Then the rest of the cooling parts were all Corsair's HydroX components, which include the XR5 360 radiator, chrome fittings, 14mm acrylic hard tubing, and the XL5 red transparent coolant. So let's talk about the thermals. XMP and Precision Boost are both enabled. When I moved the components over to the OCV1 from the Mobius, I literally kept all the settings the same for all the mentioned reused components. Then I tested the system at two fan speeds, 50% and 75% on the Corsair ML120 Pros that are mounted on the radiator. CPU first. Over a 15-minute Cinebench R23 stress loop, the delta between the fans running at 50% and 75% was only 0.4 degrees C. Difference is pretty minuscule in terms of thermals here, and even compared to the Mobius results was only at most a 2 degrees delta. As for the GPU, we're looking at a more noticeable difference where it's about a 6 degrees delta for both fan speeds when comparing the OCV1 to Mobius. Side note, the Mobius build cooling components are using Noxua's NF A12x25 on EK's 240 radiator versus the Corsair ML120 Pro fans on XR5 360 for the OCV1. You'll also notice that I didn't do fan speeds at 100% this time, and reason is because I just simply won't run my system, nor can I recommend someone to run their system at 100% purely from a realistic standpoint. Running your fans that high not only is insanely loud, but will also degrade the lifespan of your fans pretty fast too. And your computer should also not need to be running fans at full blast to get proper cooling, because if it does, then you really need to go back to the drawing board. Okay, pros and cons about building in the OCV1. If you're doing an air-cooled build, it's pretty simple and very easy to do. The footprint is very small, doesn't take up a lot of space on your desk, and there's room for water cooling upgrades if you decide to do that in the future. If you're a veteran builder and want a bit more challenge for water cooling, then this would be one of them. Now, here are my general tips for water cooling the OCV1. Depending on your power supply choice, either a standard size or SFF, I would recommend installing parts in certain order, or else you'll end up opening the case back up several times, disconnecting and reconnecting things back and forth, which will complicate your process, making it not a fun build. For example, I chose to go with a standard size power supply for this build since I already showcased the SFF power supply in the previous video. Due to the tight clearances for where you plug your cables, it's best to have your radiator bracket installed first before connecting and routing your PSU cables. Trust me on this, I did the radiator last and it was a bad time. When it comes to doing your tubes and filling your loop, for this particular case, I would highly recommend having a second PSU for your filling process, because the 24 pin is really hard to get to for the jumper depending on how you route your tubes. And lastly, I really recommend using thin sleeved cables, especially if you've got a GPU that's using 3 8-pin power cables. You may have a hard time trying to squeeze some cables through the cutouts. Everything about this case is really tight, and I would attribute that to the fact that you're cramming cable management into that thin center chamber. I've tried some custom paracord cables, I've tried Telios cables from Mainframe Customs, and the default cables that come with your standard sized PSUs are most definitely a no-go, as they are all way too thick. What I ended up using were the thin sleeve cables from Corsair's SFF power supplies, but you can only get these if you buy the platinum rated ones, or you can buy them separately from Corsair's website. If there was one thing I could have done differently, is that I would have used some spacers of about 1/4 inch long in between the radiator and its mounting bracket. This is so that the airflow exhausting back out of the radiator isn't too restricted. At first, I thought the cutouts on the bracket wouldn't be enough, but it actually is. So you will still be fine with the radiator stacked right on the bracket, but I just think having an extra gap there would be much better. Overall, I think water cooling in this case is quite rewarding when you finish it, because it was pretty challenging when it came to routing cables and trying to get everything as aesthetically neat as possible. It's also nice to know that you have a lot of cooling potential for a mini ITX system while taking up a small space on your desk. So that's all for this video. Thumbs and subs if you want to see more. Let me know what you think down in the comments below. Thanks for watching, and I'll see you in the next one.